I've hooked up a Vision Pro V400 laser rangefinder to my oscilloscope and put my test probe on the high voltage feed to the laser diode driver. And we're looking at the pulse trains right now. I'm kind of surprised that the voltage is so high. I'm measuring over 100 volts coming out of this, I'll call it the driver board, but really the small one is the driver board. But this is putting out digital pulses into the launch board with the laser diode soldered onto it. You can't see any light coming out of it right now because with my iPhone it has infrared filtering and it just won't pick it up, even though it's about 75 watt peak pulses coming out. Looking at the screen here, you can see there are some pulse trains. There's some 4 long ones and 4 short ones. I don't know exactly what those are, the tall ones. Maybe that's just a resync between short and long. But if I move the timing, the horizontal sweep timing, we can look at it real close. And you can see that within those pulses, or trains of pulses, there's smaller ones there. The scope is showing those at about 6.7 milliseconds for the larger ones, but in between you can see, where is it? Right there. There's some shorter pulses. So I'm going to move my timing, my sweep timing, so we can look at those if I can catch it. I'm not catching them. Go real short. Yeah, I'm not catching them. At least I can't see it. I'm not sure what I'm looking at. But anyway, what I really expected to see here was some pulses in the nanosecond range. Even though this is a 200 megahertz bandwidth scope, it will go on down to measure down to a nanosecond. It's just the resolution isn't very good at a nanosecond. There's 2 nanoseconds, 1 nanosecond. I'm not seeing those pulses there. So they're a lot longer than what I expected they would be. Perhaps they don't have to be that short to work. They could send out a lot longer pulse with time in between them, still get your time of flight delay and measure distance. However, the laser diode puts out peak power at the shortest pulses of between 1 and 10 nanoseconds. Because of that, and my expectation that this would put out pulses that short, either there's something wrong here with my setup, or my expectations are just completely wrong on how short those pulses are, and that it's really not putting out the peak power I think it is of 75 watts. Now, when I talk about the peak power being 75 watts, that's at these short pulses. The average power is much less. Since this is a class 1 laser, they're required to be at 7/10 of 1 milliwatt, which is 7/10 of 1,000th of a watt. There's just very minuscule average power. You don't feel anything. I can turn this towards my camera here. I just accidentally knocked the probe off, so it's not showing it, but you see nothing on the camera. I have to use a camera that has no IR filtering in it to pick this stuff up, and I have filmed it or videoed it that way in another short YouTube clip you can look at. Let me get this probe back on there. But wanted to get you guys a look at what I'm seeing for the pulse train, and if anyone can help me out understand what's going on, why this laser diode is being pulsed like that, and why the pulses, when you look at them close, are only 6.7 milliseconds each, at least on the larger digital trains. I'd sure like to understand what's going on. Please leave a note or give me contact information, because I'd like to talk about this. I'm not able to get anything out of China where these are manufactured, which is understandable. But the language barrier itself is a block, but they're not willing to talk to me.